Okay, so today's lesson kind of ties in the last two parts of this topic, which is linear relationships. So I'm going to review some of the stuff that we did last week, and then I'm going to introduce the final phase of it, which is really not that bad. Okay, the first phase of what we've been talking about, which is what we did last week, was the slope-intercept form of an equation. Okay, we can take a relationship between x and y, and if it's linear, it will fit in this form. Okay, y'all have been dealing with this form for a long time. What is it? Y equals mx plus b. Okay, m is our slope, b is our y-intercept. Okay, now we've spent a lot of time talking about slope, but just for the sake of the video and the chance to review it later if you need to, I want to go over the different things that make up slope. All right, slope is more commonly referred to as rise over run. You guys say that all the time. Okay, that really only helps us when we're actually graphing the slope or we're looking at a graph. There's going to be several instances this year and in the future where you don't even have a graph. There's no graph involved. And you still need to be able to find your slope. Okay? Slope is actually found by doing the change in y over the change in x. Change in y just means your vertical change in a graph. Change in x is your horizontal change. The change in your dependent variable over the change in your independent variable. Okay? Slope is also known as a rate of change. You're going to see that term come up. Find the rate of change. Blah, 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 blah. The reason they don't just say rate of change all the time is because slope only talks about linear equations. Okay? So if that rate of change, how much your relationship is changing, stays constant, goes up and over at the same rate forever and ever and ever, that's going to make it a linear equation. That's when it's slope. Okay? You're going to see equations later on where the growth is exponential. And we've talked a little bit about that. That's where it's going to get steeper and steeper and steeper. All right? It's no longer going to change at the same rate. So you don't have a constant rate of change. You don't really have a slope. Okay? So slope only applies to linear equations. All right. So if you're given points to do change in y, you would just take any point minus the other point. Any point minus the other point. Okay? It tells you to take the second y minus the first y, all right, of your 2 points, and then take your second x minus your first x on the 2 points. But I'm going to let you know it doesn't matter which order you go into. You can do the first y minus the second y. It doesn't matter. Okay? So long as you stick to that direction. If you start with point A, then the next time you do it with your x, you're going to start with point A as well. Okay? So slope is nothing new. We've reviewed this over and over again. Y'all know it from last year. Shouldn't be a big deal. So slope-intercept form is fine and dandy, but then that leads us into what we did on Thursday and Friday. Thursday and Friday, we talked about how to come up with an equation if you don't know your y-intercept. Okay, if we had a situation like this and it crossed right there, I don't know what that y-intercept is. Okay, but I could find, let's say I found 2 points on the line. Okay, now I can try my other form. What's the other form called? Anybody remember? The point slope form. Okay, if I have 2 points on the graph, all right, if I have 2 points on the graph, I can find the slope, the rise and the run. Pretty simple. Change of y over change of x. And if I have 2 points, I obviously have a point. Okay, so this formula, which some of you probably still remember it, is y minus y1 equals m x minus x1. Okay, the y1 and the x1 represent the x and the y of whatever point that we know is on the line. M is still the slope. Nothing different there. Okay. The trick here was when you saw something that was already in the form, all right, my x is actually a positive 1 because it was minus up here. My y is actually the opposite. It's a negative 2. Okay, and we talked about that quite a bit last week. Okay, so that was point slope form. All right, now the last form that we're going to see is called the standard form. Okay, standard form. It's funny they call it standard form because it's what you're going to use the least. You're going to use this the least of all of them, and they call it the standard. But it is good to know, especially when we're trying to find intercepts. Okay, standard form looks like this: ax plus by equals c. All right, now we don't know. Nothing in this equation, this is why y'all use it the least. It doesn't tell us the slope, and it doesn't tell us the y-intercept. Okay, it doesn't give us that information. Okay, I'm about to show you. All right, so if we had an equation in the standard form, this is an equation in standard form right here. 2x plus 3y equals 18. Now, changing this into slope-intercept form, really not too tough. Okay, I would need to move this 2x over. So it would become 3y equals negative 2x plus 18. Lastly, you would divide by 3. So you would get y equals negative 2/3 x plus 6. So changing it into slope-intercept form is not too bad, right? Now, that's not really the point of it. Obviously, the point is not to just change it to a different form. What makes this so useful is if we start getting into problems where they want to know the y-intercept and the x-intercept. Okay? Y-intercept we just said was 6. We just saw that just now. But here's why this can be helpful. At the y-intercept, what is the value of your x-coordinate? 0. Okay? So, if they say, hey, what's the y-intercept? All I have to do is say, well, that'll make x 0. All I got to do is solve for y. What's 2 times 0? 0. It's gone. All right, so what does y equal? 6. That's simple enough, right? I take one variable completely out of the equation if I want to find an intercept. All right. If we want to find x-intercept, which you can't really find with the y or with the slope-intercept, not as easily at least. If I want the x-intercept, all I'm going to do is say, okay, well 2x equals 18, right? Because 3 times 0 is 0. It's gone. At the x-intercept, my y equals 0, right? So, what is my x-intercept? 9.
Because all you have to do to find the intercept of 1 is just completely get rid of the other, pretend like it's not there.
Well, it's not that we're getting rid of it completely. We're just saying we know that at the x-intercept, we know that the value of y is going to be 0. All right? Because it can't go up or down or it won't be on the x-axis anymore. So really what we're saying is 3 times 0. But since 3 times 0 is 0, we don't even really need it. We just do like that. Divide everything by 2, and x is equal to 9. Eesh, that's an ugly 9. But there you go. Trust me, it's a 9. Okay, so standard form gives us an easy look into finding your x and y intercepts. Okay. All right. The only downside to it is if you want your slope, you're going to have to rewrite it into slope-intercept form. That's the only way to find your slope. All right, so here, I don't know why I'm clearing that. I'm just going to start a new one. Let's say we have x minus 2y equals negative 2. All right? With the standard form, it's really not that hard to graph this. All right? All I have to do is find the two intercepts. If I plot the two intercepts, I can make the line, right? So, for my y-intercept, I'm going to make x 0. That will give me negative 2y equals negative 2. So what's my y-intercept?
Wait. Oh, yeah, did you divide it by this?
So there's my first point. Okay. Now, if we're going to do the x-intercept, my y is equal to 0, right? So I can just take it out. I'll just be left with x is equal to negative 2. This thing. There. And there's my line. Okay. So from here, from the graph, you could go right back to y equals, my slope is up 1 and over 2 plus 1. These two equations are the same. Okay, so let me do another example. Let's go back to that first problem that we were looking at. If I wanted to graph 2x plus 3y equals 18. Okay. All right. We already solved for our intercepts, but I'm going to do them again just for repetition. If I want my y-intercept, I'm going to say 2 times 0 plus 3y equals 18. Well, 2 times 0 is 0. What times 3 gives you 18? 6. So my y-intercept is 6. So 1, 2, 3, 4, 5, 6. There we go. All right, for my x-intercept, 3 times 0 is 0, so it cancels out, and x is equal to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's our line. So graphing from standard slope is really not that bad. You just graph your two intercepts and then go from there. Okay. Okay. All right, so now that we know these different forms, it's important to understand these different forms and when to use them, but we also need to be able to convert in between the two. Okay? So, if we have, let's say you had a point slope form of y plus 1 equals 2x minus 18. Okay? So this is from the point slope formula. Well, pretty much. We'll just leave it there. All right, if you're given this, all you have to do to change something into standard form is just move everything to the left, except for the numbers by themselves. So, the plus 1 is going to go over here. The 2x is going to go over here. So what you'll end up with is negative 2x plus y equals negative 19. It's hard to see on the TV. Questions there? All right, so nothing mind-blowing, or shouldn't be, okay? You've got your three forms: slope-intercept form, point-slope formula, and standard form. Okay, if you think about it, slope-intercept form is great for everything. If you can use it, that's the way to go. Okay? Point-slope formula is when you don't have a good y-intercept. Doesn't pass exactly through a point. Okay, and so all you need to do is find a point and a slope. It's also really good if all you have is a point and a slope. Finally, standard form is really only good if you're looking for the intercepts. It's really the only time I see a need for it. Okay, but it is good to know. Now, it's important to understand also that all of these forms, y equals mx plus b, sorry, my thing glitched out. Y equals mx plus b, y minus y1, mx minus x1, and ax plus by equals c. All three of these forms will be on your formula chart during the EOC. Okay, so you don't have to memorize these. Okay, that being said, you need to be good enough with your algebra rules that you can convert between them and you can actually use these. Okay, just like a volume equation or formula doesn't help you if you don't know how to use it. Okay, so we need to make sure that we know how to use it. All right? Okay.